All right, so we got integral of x squared, square root of 9 minus x squared dx. This is 46 and 7/4. All right, so somebody up front asked about it. Is that you? 46. What did you guys do? How'd you start?
I made x equal 3 sine theta.
Yeah, I'm cool with that. And so let's see if I can have everyone here. Then dx would be what? 3 cosine theta? D theta? Right? And so let's go ahead and make those substitutions. So the top should be 9 sine squared theta. And then the bottom should be, briefly I'll write it like this, 9 minus 9 sine squared theta. And then you should have a 3 cosine theta over here, d theta, because you got to change your differential, right? All right. Everybody comfortable if I do this? Let's see. 9 sine squared theta, 3 cosine theta, d theta. The bottom, if I pull the 9 out, I can square root it separately, right? And the rest is going to be cosine squared theta. You're going to end up with a 1 minus sine squared. Right? Do I need to put in steps in the middle, or are you guys okay with that? Okay, so square root of 9 is 3. And cosine squared square rooted should cancel with cosine, right? Okay, so you should end up with 9 sine squared. Is that the problem? All right, so let's see. You have 9 sine squared theta, d theta. You have two options. One is to do integration by parts. The faster one is one of those identities on the front of your sheet from this section. Let me pull the 9 out. Sine squared is 1/2 minus 1/2 cosine 2 theta. Right? And cosine squared has the plus in the middle. And that makes it much easier to do. Okay, so now when you integrate, this is going to be 1/2 theta minus 1/4 sine of 2 theta, because I did a w substitution in my head, right? The w equals 2 theta. If I took the derivative, I would multiply by 2, right? That's sine of 2 theta.
Wait, you can just leave it like that?
No, I got to go back to x.
Okay, that's right.
Right? So I have two problems. One is I have a theta. Let me use a different color. I have a theta, but I also have a sine of 2 theta. Okay? So maybe that's the tougher part. Now, way back when, so just remember theta and sine of 2 theta. Way back when we made x equals 3 sine theta. Right? So theta then is just arc sine x over 3. That part's not so hard. Right? The trickier part is sine of 2 theta, right? So
what was the integral again? It was when you took the integral, it was what?
okay, so we have theta, and now I'm going to think about sine of 2 theta, and this is pretty tough to think about how they're related, so I'm going to use an identity. This is, which maybe this isn't one you remember, but this is 2 sine theta cosine theta. That's yet another trig identity. There might be a way to do it with triangles that's quicker, but I think that's the quickest way. And so I have sine of theta, right? Sine of theta is x over 3, if you look at the top line.
Yeah.
So the next trick is figure out cosine, right? Well, cosine, remember, is cosine squared is 1 minus sine squared. So I would write it as the square root of 1 minus sine squared, which is x squared over 9. And that whole mess would be, I'm hitting the watermark now. That whole mess would be the sine of 2 theta. Who assigned this awful problem? There's like lasers coming right at my face.
This is the square root of 1 minus x squared.
Yeah. All right, so I'm gonna kind of stop here, but once you plug those back into the antiderivative, you should be done.